हो गया? Okay. Good afternoon to you all. As you know, I am GP Singh. From Savan Coaching. Again, I am repeating. Here at this forum, we are providing free education to the students for preparation of various exams. The various exams cover IIT, JEE, and NEET for medical preparation, entrance preparation. Few classes are also running for SSC. Also, with help of our associate, with help of our magnet brains, right? So, in the physics, we were studying Newton's law of motion, Newton's laws of motion. And as I have told you, these laws of motion given by Newton is of central importance. The laws are given here are of central importance in the field of classical physics. So yesterday we have seen a few examples and few laws, and also we formulated the second law of motion. Now let's give some example which will help us to understand how we apply the force and how can we consider force in a particular system. First thing is extended body. Extended body. In most of the case, it is considered that the body or object on which any force is being applied on or any force is acting on it is a point mass. But practically it is not possible that all the masses are point mass. So in practical cases, every physical object has some volume, extension, has some length, breadth, radius, diameter, height, etc. So extended mass is the mass that may also be considered for the force, and after applying the force, what happens to this body, this object. So these laws hold good, equally good, provided that whole of the body move simultaneously. There are no relative motion between the different parts of the body. All move with the same speed and acceleration, etc. Like you have seen the army men doing parade. They all move with the same manner, same velocity, and with highest degree of precision. Although it is a little unusual sort of example, but that also a very good example. It's very good to watch them during the parade. But that is not an example. It's just a human. Any physical body remains unaffected by the external force in the manner that it doesn't, its internal structure doesn't get disturbed. Suppose we hit a stone with the help of a big hammer. It may move, but a little part or a part of it may also break from the main body and may move in some another direction. So that will be different case. But if after hitting the stone, if the whole of the stone moves in the same direction with some acceleration, of course, then it is an extended body and there is not any part being separated from it, then the law will hold good. This is a concept of extended body, and the law will hold good and it is holding in the case of a point mass, right? So this is the case. Another example is also there. Suppose I am having one block here, another separate block put on up over and above the first block, and it is tied with the string to another block. Then again it is going through a pulley, another block, again it is going through a pulley, then another block, and one person is pulling it. One person is pulling it. So you can see there are more than one, आवाज जा रही भैया? More than one objects are there. 1, 2, 3, 4, 5. But these are, all of them are being pulled in this direction due to pull by the man. It is moving in such a way that there is no relative movement between this block and this block. They are moving with the same speed, velocity, or acceleration. Right? Now, it is being pulled in such a way that all of them moves with the same speed and covering same distance in a particular time period. Suppose it is moving 1 meter in 1 second, this also moving 1 meter in 1 second, this also moving 1 meter in 1 second. Then this whole setup may be considered as one system, where one force is there and having the equal effect on each and every object, right? So this is an example how we consider the force and frame of reference and the setup, etc. Now one more example. The diagram is there, is given there in the book, and I am not very good at drawing, but still I will try to draw the diagram. So roughly this is the diagram. I desperately hope that you understand this diagram. A man holding a box on his head, right? A man holding a box on his head, right? There are various forces acting on this situation. Likewise, yesterday we discussed table is there and book is kept on the table and there are so many forces. This is almost identical case. Book kept on a table and the table is kept on the floor of the room. Likewise, this man is standing on the floor or any field or any ground, and he is holding a box on its head, on his head, right? So let's consider what are the forces, and there is no movement. There are forces, there is no movement, there is no acceleration, there is no displacement or any sort of thing. So there are so many forces acting. It's the man weight, earth contact force counterbalancing this weight, this box weight, and a contact force through its head opposite to its weight, right? These are the forces acting on the system at one point of time. But as we know, that if there is no acceleration, then the resultant force or vector sum of all the forces acting on various part of this system is 0. Correct? Is 0. Now let's draw a table. I guess this page has not enough space, so I will add another page. So what is system? There are two systems. One is boy or man. Sorry. Man. Another is load or box. Correct. Now, on the man, what are the forces? And who is exerting this force? As you know, Earth is pulling it. Earth is pulling it downward with its weight, and the floor is balancing this force by the contact force. And this force is gravitational. And this one is EM force or contact force. This is the nature of force. Contact force is categorized in electromagnetic force category. What we have studied, that there are four categories of forces, natural forces: electromagnetic, then gravitational, then nuclear, and then B. So contact forces are categorized in EM force. Now on this man, this is also exerting a force, that is load. A load is also exerting a force. Where it is exerting? It is exerting downward. This is also contact force. Contact force. There are three forces acting on this system. Another one is box. On box, Earth is exerting one downward force, that is its weight. That is downward, and which is what? It is its weight. You can say W dash. And one force is exerted by the head of that man, that is by this man. Man is exerting one force equal to this one, which is acting upside. This is gravitational and this is contact. Contact, right? So this is the chart depicting various systems, or you can say subsystems. System is one, and we have bifurcated in two systems. One is man, one is box. and we have demonstrated how many forces are there. Fact is, the total sum of all the forces is a big zero. So the boy can feel exertion if the man can feel exertion if we ask him to stay for at 1 hour, 2 hour, 3 hour, that is not possible, and he will feel exhausted. And again, that is another case, though there is no work done. He is not doing any work as per the definition of work, because force is there, but no displacement is there. Still, he will feel exhausted. So, this is the case, and its diagram may be made. Diagram is already there. One more thing is there. How to display on X, Y axis. XY axis. Suppose there is a system in which one force is applied on one ball, and ball is moving in straight direction. There is no upward or downward movement. This is the simplest example. Therefore, you need only one axis. This may be in any direction, like this direction. We were discussing one boy sitting in the train compartment and tossing the ball upward and then coming down and catching it again, tossing upward, then again catching, tossing upward, then again catching. In this case, there is only one direction. He was applying force to the ball, and ball is going up, and again with the in the influence of gravity, it is coming down. In that case, or in similar case, you need only one axis. Whether you can say it x-axis or y-axis or whatever axis you call. In such cases, you are supposed to choose the direction of motion as the axis. Direction may be in this direction, in this direction, in this direction, in this direction, or in this direction, or any direction. So it is wise to choose the direction of acceleration or movement as the axis. Normally, such cases are few in number. A wide variety of cases, a large number of cases are such that the force or velocity or acceleration takes place in simultaneously in two directions, like a ball going like this and coming down like this. You throw a ball, the ball will go and come down again in this manner, right? You drive a vehicle on the road, and you will move like this. It's a random motion, and then on the crossing you may take a turn in this way, and from there you may take a turn in this way. So such movement are biaxial, दो एक्सिस होते हैं, two axial axes are there. So in that case, we draw the various components of motion in such form that is very common form, that is x-axis and y-axis. So this diagram may not be superimposed on x-axis and y-axis, but when two variables are there, like time and distance, in uniaxial case also, unidirection case also, we may have biaxial plots, because time is running out, time is moving, and distance is being covered. So in that case, time and distance are plotted on two different axes. It is not that when moving in two direction, then only you will draw biaxial diagram. When there are two factors involved which we are measuring simultaneously, that distance and time, or acceleration and time, or speed or velocity and time with time, or maybe another thing. Distance and acceleration may also be case where we can may be required to plot. So we can have biaxial plot. Usually we draw time on the x-axis. Sometimes it is taken that acceleration along the x-axis. It depends upon where it becomes easy to understand and easy to process further the data provided by our experiment. Right? It totally depends upon the person who is drawing the graph. Suppose one person has drawn graph in different manner, you cannot tell that it's wrong. It's also right. So let's move on to the another example. Another example. Suppose there is a block, there is a floor, and a block is placed here, and a string is attached, and that is being pulled by a man. Right? It is supposed in this situation that this surface is not having enough or observable friction. It is smooth practically. It is smooth surface, and this is being moved by, this is being pulled by the man. ये चल रहा है क्या वीडियो? इसमें आ नहीं रहा। सोर्स एरर बता रहा है, ऐसा नहीं चलते चलते एंड स्ट्रीम हो गया हो है? अच्छा ठीक है, इसमें नहीं चल रहा है, तुम्हारे मोबाइल में नहीं चल रहा है। आ रही है। So let's discuss various forces acting on it. As usual, weight is acting downward, contact force is acting upward, and one tension is pulling it in this direction, and this tension force has two components, that is T cos theta. This is, sorry, this is angle theta. So along the x-axis, the force is T cos theta. Along the y-axis is force T sin theta. Correct? And the mass of this block is m. So now consider the various forces acting on it. A force is being applied, and we will not going to consider the friction force acting between this body and this floor. So in this direction, we are applying a force T cos theta, and this is causing an acceleration, that is ma, right? Okay, this is horizontal direction. Because another force being exerted on this mass is weight and contact force. They are not having any horizontal component. So along the x-axis, this is not having any component, this is not having any component, this only, and only T cos theta is having a horizontal direction, and that becomes equal to T cos theta is equal to ma. Force is equal to mass into acceleration, right? So what are the components acting on the vertical plane? That is N and T sin theta, and this is Z. Is that clear? Sorry, G. It is mg. So T sin theta plus N is equal to mg. Clear? In this manner, we are having MA. We are having P is equal to MA upon cos theta. So, this T may be replaced as MA cos theta into sin theta plus N is equal to mg, and this becomes MA tan theta plus N is equal to mg. Here you can calculate the value of N. Value of M is equal to value of N is equal to mg minus MA tan theta. This is simple replacement method and very simple with the help of a little mathematics. Right? So this completes the, as per this book, this completes the study of Newton's first and second law. Now we will try to understand what is the Newton's third law of motion. It's also very famous. To every action, there is an equal and opposite reaction. Almost it is used as a part of humor among friends and colleagues. When we play football or any other games or boxing, we use this third law of motion, statement of this third law of motion, that every action has an equal and opposite reaction. And with this, we reciprocate and a punch to our friend which has just hit me by one punch. Normally, this is opposite but may not be equal. If he is hitting one punch, I may give him 5 punches. So, but we use this dialogue very much. To each action, there is an equal and opposite reaction. Right? So, this is the humor of physics. The body A exerts a force F of another body, then B exerts a force minus F on A. If a body A exerts a force on B, this force simultaneously B start exerting a force minus F on A. This is the another statement of this law, right? Actually, what we find here, that only the second law motion is the original law. The first law and the third law are only another type of stating the fact which is being contained in the second law, that we can easily understand. So, we have just seen an example that man is holding a box on his head, and the box is putting a pressure on its head, and the head also putting a equal and opposite force, that is contact force, so that box does not come down or crush its head. If the head is not exerting an equal and opposite contact force, the weight of box will crush the head of the man. Sometimes it happens that you put a weight much beyond your capacity. Like you have seen some weightlifters, they try to pull that weight, and when it becomes beyond their capacity, they simply drop to the ground because they cannot pull it up, and the weight of that object is such that they cannot apply a contact force opposite to its weight, and it come down crushing, and they simply throw it to save themselves, right? So this is the example where A puts a force on B, then B puts a negative force on A, right? In this manner, we can हाँ जी, कहाँ? हाँ, हम तो यही कोचिंग पे हैं, कहाँ पहुंचे? हाँ, हम यहीं पे हैं, कहाँ आप पहुंचे अभी? कैंट में? ठीक है, आओ। तो this is in this manner we can understand the third law of motion of as stated by the Mr. Newton. And this all we can understand with the previous examples, that a book is kept on the table, then table exerts an equal and opposite contact force, and the book exerts a force equal to its weight, mass multiplied by the gravity. And there are so many examples, like a string. A string is there, a weight is being hanged from the ceiling with the help of a string. So mass is working in this direction and the tension is working in the opposite direction. And when it happens that if we gradually start increasing this mass, then at one point the capacity of this string is overpowered by the weight, and then at that time the string breaks down and the whole weight comes down. It's beyond its capacity and the string breaks down. Simple. So these are the examples with which we are there are few more examples. You can read the book and come up with your theories. From tomorrow, we will start the chapter of friction, and with this, I am completing this class, and I expect you to study the rest of the points or any point left by the in this lecture, right? Okay, thank you very much.